All right. 2023, day 13. Advent of code. Let's go. Day 13, point of incidence. With your help, the Hot Springs team locates an appropriate spring which launches you neatly and precisely up to the ledge of Lava Island. There's just one problem: you don't see any lava. That is a problem. You do see a lot of ash and igneous rock. There are even what looks like green mountains scattered around. Mr. Robot Man, thank you. Thank you for the follow. After a while, you make your way to a nearby cluster of mountains, only to discover that the valley between them is completely full of large mirrors. Right? Most of the mirrors seem to be aligned in a consistent way. Perhaps you should head in that direction. As you move through the valley of mirrors, you find that several of them have fallen from the large metal frames keeping them in place. The mirrors are extremely flat and shiny, and many of the fallen mirrors have lodged into the ash at strange angles. Because the terrain is all one color, it's hard to tell where it's safe to walk or where you're about to run into a mirror. You note down the patterns of ash and rocks. Perhaps by carefully analyzing these patterns, you can figure out what the mirrors are. For example, to find the reflection in each pattern, you need to find a perfect reflection across either a horizontal line between two rows or across a vertical line between two columns. So if just two lines are equal, in the first pattern, the reflection is across a vertical line between two columns. The arrows on each of the two columns point at the line between. Oh, okay. In this pattern, the line of reflection is the vertical line between columns 5 and 6. Because the vertical line is not perfectly in the middle of the pattern, the part of the pattern, column 1, has nowhere to reflect onto. Oh, I see. Okay. All right. Every other column is reflected column within the pattern must match exactly. Column 2 matches 9, 3 matches 8, 4 matches 7, and 5 matches 6. Okay. The second pattern reflects across a horizontal line instead. Yep, I see it. And then we ignore row 1. Row 1 doesn't need to match anything. All right. I'm following along. To summarize your pattern notes, add up the number of columns to the left of each vertical line of reflection. To that, also add 100 multiplied by the number of rows above each horizontal line of reflection. So to the left and above. Okay, in the above example, the first pattern's vertical line has 5 columns to the left, so we get 4 or 5. What number do you get after summarizing all of your notes? All right. Well, let's deal with the input first. I'm going to go to my AOC library initially because I think I had a function which will read in records. Yeah, which is a vector of U's here, and it'll split on blank lines. Oh, no, these are numbered records. Here's. No, I don't have it. Okay, so we'll just have to make it up. Let's do this. Suncheck, thank you for the follow. Welcome. All right, day 13, moving away from the dreaded day 12. Let's see. 23, 13. Okay, and we're going to have this problem here with this on day 12, so I might as well switch day 12 over. Yeah, it's just this here. And we'll come back to that another day. What's going on here, though? Unused import. Oh, did I mess it up? I messed it up. Yeah, here it is. There we go. Now we got it. Okay, let's go here. And now I don't have my normal library routines. So I'm going to have to just do it by hand here. Let data equals standard fs read to string input 2023. Oh, I haven't even gotten the input text. Expect missing file. Let's get the input. Uh, 1,349 lines. But I guess it's just a bunch of blocks. Let's take a look. See what it looks like. I was just about to ask, are they all the same width? But no, they're not. They're all sorts of different widths and heights. Okay. Ooh, I can see the vertical reflection on that one. I wonder if part 2 is going to be like, now that you've been able to reflect them, try to assemble them in some sort of a semblance of order. All right, we can count how many there are by saying grep-v on hash. Every line's going to have at least one hash, right? On that. 99. So there's 99 gaps, which means there's 100. We should have 100 patterns. Let lines equals data lines. All right, so we need to generate these patterns. Let's, do I need a struct, or can I just shove it in a vector of U64s? I guess what we could do, vec of U64 and then score. So, because we have to score each one, right? Each one gets either a vertical number or 100 times the horizontal number. So we can just put that in here. So we can say for line in lines, this is going to be patterns, the vec of pattern. And then what we'll do is say let mut pattern equals vec new. We have to convert each line now. If, well, first we say if line is empty, we've hit a blank line. So we're going to generate a new pattern. So we'll say self patterns push pattern of pattern and score 0. Yeah. Else, we'll convert the string and push it into this pattern thing. Oh, which means we need to generate a new pattern here. Pattern vec new. Right? And we'll just say pattern dot push pattern convert line. And then the last one, there might still be one. If there wasn't a blank line at the end, if not pattern is empty, self patterns push pattern score 0. And then here we can just print out the number of patterns we got. So we can see if it's 100 or not. Impl pattern. Let's do the convert from a string. Let's do a s stir, which generates U64. And the reason I'm using U64 is because I imagine I'm going to be doing bit shifting here. And I want to make sure it's wide enough. All right, conversion should be straightforward, right? We're just going to be walking through the string, convert each one of these to a each hash to a 1, and then bit shift. I wonder if I could do it functionally. This is what I'm saying. For C in S, let mut result equals 0. For C in S, result equals result shifted by 1, or C is equal to hash as U64 result. Can this be done functionally? Maybe with a fold? Probably with a fold, right? Let's write a little test. I have a little, I don't have time to do this, but I'm going to do it anyway. Convert, test conversion. And we're going to expect, I don't know, 10 out of pattern convert. Right, that should be a 10. All right, day 12 fails. That's not going to be helpful, is it? 198. Oh, all of these fail. Okay. There. All the tests pass now. Although we have this problem here. Don Shock, thank you for the follow. Mod says you can split by NN. Yeah, I could, but I'm just doing it this way. So this is straightforward. I assume this worked. Let me try a failing test. Let me change that to 11 just to be sure. Yep, okay. So I think this works, but like I said, I think we can do it with a fold. schars fold 0 ACK ch ACK shifted by 1. It's just basically this, right? Without the semi at the end. H. Yeah, okay. So hardly worth writing a separate function for it. All right, so now we just need to loop over every pattern and find its score. Right. The werewolf. Thank you for the follow. Welcome. For, I don't know, P in self patterns, we have to mutate them because we're going to be setting the score, right? So we'll say P dot score. And then this is just going to be the sum of self patterns. Map P dot score sum U64. Right, now we just have to write the score. Mohad says, so are you representing each row as a number in bits? I'm representing them as a vector of bits. So if we print out, let's print out the first one. I have debug on, so I can just do this. Self patterns of 0, like that. Oh, I haven't written score yet. Let's just do that now. Fn score, self. What self, right? Because we want to update the score. Let's just do that. Oh, iter map. Yeah, so it's just a bunch of, it's hard to read, I guess. It's a bunch of bits, right? So this is the first one. And I guess what I could do is for row in self patterns of 0 dot pattern, iter, println, I don't know, let's say 10b. I don't know how wide it is. Row. Well, it didn't work exactly the way I was hoping it would work, but maybe we do that. I guess 20. There we go. Okay, so it's just like this, and if we look over at the test input, it should match. Let's find out. 2023 13 text. Oh no, not under source, it's under input. So we have a 1101, right, at the beginning, 0 0 1 1 1 0, and a bunch of ones. So we just have a bunch of things like that. So I guess it worked. And what we probably need to do I was just thinking the way we can do the reflection is just, we can shift one bit at a time and see if it reflects back to what we were looking at. Probably need to know the width. Let mud width 0. Width equals line len. Width. If I want to add more stuff to it, I'm going to probably have to create a new function. All right, so and this tells us the width, and that would allow us to do this at least. Like that. Oh, it should be W. There. And now we get the exact width. All right, so now we have to figure out how to do the score. I guess this is where all the hard work happens. We can just split it into a horizontal and a vertical. Can it do both? It says either horizontal between two rows or cross vertical between two columns. Does that mean I just need to search down for where two consecutive lines are in a row? I guess not. I guess then you'd have to work your way backward and make sure the ones subsequent to it and preceding it all match. Right? But it's either. It says either horizontal line or across a vertical line. So I guess if we do a search and we find a horizontal line, we don't need to find the vertical line. Because it doesn't say we find the, the higher of the two scores or the deeper of the two numbers or whatever. So we can say, let's create a horizontal on self, which returns us a U. Am I doing U sizes? Oh no, I'm doing U64s. Let's just return 0 and then vertical. I should make it an option, right? Let's do it this way. Option U64. Now we can hit dot. I can say if let sum horizontal equals self find horizontal, then self score is equal to horizontal. It was times 100, right? Number of rows above each horizontal line. Okay, times 100. Else, if let sum vertical equals self find vertical, self score is equal to vertical. If there is no score, what do we do? I'm just gonna print something out for this. Could not find score for, I don't know how we can identify these. A pattern. If this happens, then we can dig into it. Okay, so find horizontal. What do we need to do? We need to work our way down until we find two that are the same. And then we can work backwards until we hit the beginning or forwards until we hit the end to make sure they match all the way. So we can say let position is equal to self pattern as slice Windows 2 find pair where pair of 0 is equal to pair of 1. That'll only find the first one though, right? Oh, and it doesn't give us the index either. Maybe we just do it by hand. For I in 0 dot dot self pattern len minus 1, because we have to look forward by 1, if self pattern of I is equal to self pattern of I plus 1, then we want to keep looking backwards on I and forwards on I plus to make sure they're all equal. There was test input, right? So we don't have to do this in blindly. Yeah. So let me copy that. And then I can just run the test input here. Okay, so find horizontal. If we found two patterns that match and we want to back up to 0 and we want to forward until we hit the pattern length, whichever comes first. And if everything matches, then we're good. How do we do this? So we can say for j in 0 dot dot I reversed. Can we do that? Seems to be okay with it. So now we want to say, we want to do 1, right? Because we want to say if self pattern of j minus I. Oh, this is only going to go to I. We have to go to equals I, right? Is not equal to self pattern of j plus I. And I'll put in a guard in a second. Then we're going to go to the next I. Continue next try. Right? Next try. But we have to make sure that j plus I is less than length. Let len equals self pattern len. I guess I'll be using it more than once. So we want to say if j plus I is greater than or equal to len, then we found a pattern. And so we want to return it. Return some I, right? If we get through this thing and everything matches, then we can return some I as well. And if not, then we return none. All right, let's see if this works with the test input. Ready? I guess I have to get it to compile first. As U64. Should I just do U sizes for everything? The only reason I'm picking U64 is if U size happens to run on a 32-bit machine and we have some patterns. I don't know. Are there any patterns that are bigger than 32 bits? It doesn't look like it. All right, let's just switch everything over U64 to U size. None. Could not find score for, that's okay. Oh no, it's not okay. We should only have seen that once, right? One of these should have reflected horizontally. Okay, so let's debug this. Print len found match. So it found a match. Yeah, so this one that's printing out actually has the horizontal reflection, right? Yeah, this one matches this line matches that line. Okay. Oh no, it doesn't. Okay, so it must be this one that does the horizontal match. Yes, so from here to here it reflects. So I just got to say found match at I and see if we find it. Found match at 3. So 0, 1, 2, 3. Yes. Okay. But then I guess this didn't match this, or we didn't compare them properly. println comparing with j minus I, j plus I. 0 with 6. Oops. Oh, I have it backwards. I minus j and I plus j. Yeah. Huh. Why is it 0? J starts at 1 and I is 3. Why is I minus j 0? Oh, because I'm going backwards. I'm a dummy. Okay. Yeah, let me just go backwards normal. All right, so that's better. Now it's comparing 2 with 4, but apparently it didn't work. Nope. Okay, so couldn't, so 2, which is this guy, and 4 with this guy, they didn't match? Why are these not equal? I'm going to print them out and see what they look like. This is bizarre. This wasn't supposed to be the hard part. This was supposed to be the easy part. Comma. Nope. Still no good. Oh, here. 4 with 502. Wait a minute. I'm confused now. Comparing 1 with 90? 385? Oh. Why is this 502? Did I mess up my conversion? Scoop says print in binary, yeah. I mean, but they're clearly wrong. Oh, that should be a B, not a question mark. I'm so used to question marks. All right. Oh, I meant to go here. And this is this pattern. That's correct. But for some reason, we got this weird business here at 4. Why? What did I mess up? Conversion, I mean, I'm starting at 0. Oh, you're right. 2 is 5. You're right. I have to add one to it because I plus j is already the. And then it panics because we blew the thing. That's what I was trying to prevent from here. 103. Huh, it died here, but it didn't die up here? Unless this is, oh, this is 103. Okay. 0 with 7. Right. So j plus I plus 1 is greater than. There you go here. No. Scoop says another plus 1 on the if j plus I is greater than. Oh, yeah. So I went backwards on that. There we go. All right. So we got a score of 300. That's wrong, isn't it? Because it would, I think it's at 405. Yeah. So it found a match at 3, 0, and 2. Oh, I got to add 1 because we're starting at 0, not 1. Yeah. 400. Okay. So that's that. Now we can turn off all of that. And actually, I want to turn this off as well. Right? Makes the code a little noisy, but there we go. Okay. So now we just need to do the vertical one, which is going to be the harder one, I think. Because we can't just look for a column. I mean, we could do it like a rotation and then do a find vertical. Right? If I rotate everything 90 degrees to the left and then do a find horizontal on the rotation, how hard would that be? Oh, I'd have to create a new pattern because I have this code in here. All right. Well, I mean, this can't be too hard. What we can do is we shift each bit down to the right into a new pattern that we build to the left, and then we just compare equality against the bits we've gotten so far. Right? And we can say let mut bits so far equals 0. And then we can say, and this is why we needed the width for, no, let's create a duplicate. Let's call it pat, self pattern clone. Oh yeah, self pattern clone. This will give us a new copy of all of those guys. And then mut reflection, self pattern, no, vec of 0, usize, semicolon, self pattern len. Width. No, len, pattern len, because we have to search the whole thing. Okay. Scoop says, I would think it'd be easier to just make a new pattern vec doing the shift and push. Well, I mean, this is what's in my brain right now, so I'm not sure. A new pattern vec. So here's what I was thinking. So we can, while, I don't know. Let me do 1 and see what it looks like. Basically do the rotate. Yeah, that's kind of what I'm doing, right? If I say for pattern and reflection in pat dot intermute dot zip reflect intermute, what we can do is say shift everything over, reflect, no, star r is equal to star r shifted by 1 or p star p and 1, and then star p, p shifted equals 1. Right? And that way we build up the reflection, and then the bits so far, this will be in a loop. Bits so far equals bits so far shifted 1 or 1. I don't know, something in 0 dot dot self width. Oh, come on. Nope. Okay, there. And now we can compare the bits on each side for I in 0 dot dot pattern len if pat of I and bits so far equals reflect of I and bits so far. Oh, not equals, right? Then we'll say continue next bit. If we get through all these, then we found a match. And I'm sure I have an off by 1 error somewhere. Return some self width minus I, because it has to be from the left. Nope. So it does need to be a star. Self pattern len. 406. All right, so I'm off by 1 here as well. It should be 405. And let me get rid of the nope. Where's the nope? There's the nope. Don't need a nope. All right, so we have that. Should we try to hit the real data? Let's see where we. Ooh, yeah, okay. Could not find a score for pattern. Is every pattern guaranteed to have a score? But I probably have an off by 1 somewhere. All right. I can dump the pattern that I can't find score from. Does it say that everyone has a pattern? I guess that's implied. Good Monk says yes, every pattern has exactly one reflect. Okay, all right. So we got to fix the bugs. Here's could not find. So let's print out the pattern we couldn't find a reflection for. Println, no. We'll do the same thing we did up above. Without the config test business. Is there anything we need to print out besides just the pattern? We don't need the score, and we have the width in our eyes. So just should be self pattern width and self pattern iter. Yeah. Oh. And self width. All right. So let's take a look at this pattern and see what I do see. These two lines are the same. Oh no, there's a bit here. Okay. So maybe there's a vertical. Yes, I see it here. This column here. So this should be a 1. We should get up a 1 out of this one. So that means our find vertical doesn't go far enough. Mohat says it's implied when it said either vertical or horizontal. Okay. I should have been paying more attention to my reading. What we can do is we can generate just this as our test input and then use that. I do need to change all of the 1s to hashes. The 0s don't matter because I only look for hashes. All right, and then we'll go back here. Back here, and then change this back to test input 1. All right, and now I can dump everything out. Okay, very good. All right, test input 1. We run it, we get 0. So now what I can do is I can dump out what's not matching. This is 8, so 8b, and let's do that this way. And 0, 8b, matching with 0, 8b, and 0, 8b, like that. And now we just do all these guys here. There, change that to a comma. Oops, like that. There we go. So we're comparing the 1 with the 1. Ooh, this went extra. Oh. This is what's in the pattern here. Right? let's say where we're starting, because we're looping over. Oh, why are we continuing past this? I guess we're trying each line to see if they're all equal, but then this goes up to the next bit to shift everything. I'm reusing I, but that shouldn't matter, right? Let me rename this to J, just so that things are consistent here. Actually, I'll rename it to row, right? Because that's what we're doing. We're checking each row, and as soon as they're not equal, we should go to the next bit. And that's what we're doing. But I think I'm messing this up. Because these last two lines have to be... Oh, I don't want this to be more and more. I want this to be less and less on this side. Oops. Okay. Mut pat bits equals 1 shifted by self width minus 1, right? And that's what I want. And then this gets shifted here, and then this pat bits gets shifted 1, and then we gotta go pat bits. I still don't like the fact that this is going too far here. This is going too far. So this should this should have been shifted down, because we've shifted 1 bit into here, and we're starting with a 0 bit, so it's a 0. Well, we shouldn't be looking at the top bit anymore. Why is this wrong? Do I want to do that instead? Yeah, and then this thing needs to be I guess this part doesn't matter, right? Because we're only going to have the bits in there that are actually present. But when we shifted down to this last one, it should have been equal, right? Because we're expecting this equals this equals this equals this. And I think we're just messing up the whole... We're never finding this pair of zeros. Yeah, I think we need to shift it down. Scoop says I shift bits so far right away. Yeah, we have to actually shift so that we're comparing the same number of bits, I think. Hermio 2, thank you for the follow. Right? As we shift more and more bits into here, we want to make sure that we're comparing, but we're looking for a comparison between, like if it's these last two columns, both of these need to be 1 bit, comparing 1 bit to 1 bit. And I think I'm doing this part right. So maybe it just needs to be on the same. There. It just needs to be in the same pattern. Okay. So bit so far is useless. Oops. Pat bits. Although it's bugging me that these are zeros now. No wonder it's equal, because it's 0. So I think I do need to switch this back here. Yeah, now it's comparing all ones. So all of these patterns with the last bit is set. Okay, and it's coming up with 1. All right, let's try the real input. Scoop says, should you be ending with only 1 bit, not the whole bunch? Yeah, so I think that was the issue. Let's see if this is still 405. Ooh, no, it isn't. It's 400. Oh, do I have to add 1? I am adding 1. Oh, up here, I mean. Find vertical. Wait a minute. Why is it 400? Zero. Okay, so it's failing on that this one now. Whoops. Oh, do we have? Am I doing the width wrong? Oh yeah, I'm doing the width wrong now because this is a test input. Let me just change these all to 16s. Yeah, it should never get to 0. So that's probably what's going on here is the pattern left with -1. No. Yeah, this one's 9 wide. Okay. Wizard said I use dynamic width for the binary. Yeah, I did that up above. I just didn't do it here. I was just being lazy. So this, where does it reflect? It reflects here, right? With 5 to the left and 4 to the right. So it should have found it a match with 10110 and 4. Oh. But there's an extra bit here. Yeah, that's why I did the self width -1. But now it goes too far because it fits. Oh no. Oh, I fixed it. What did I do? How did I fix it? That's weird. Let's get rid of the vert. Mohad says, how did I fix it? Such a funny expression. Yeah, I was just poking stuff. I'm not sure what changed. Let's make sure the other one still works. Because maybe I fixed it for this case, but I did not fix it for the case where the input is all the way at the end. That's probably what happened. No, it has 1. It has 1. Okay. So I'm smarter than I think I am. 3544. And this time it's not saying it can't find patterns. So that's good news. But it's not the right answer because it's too low. What? How could that be? Could some of these patterns have double? But I'm doing if it's horizontal, then do that. Otherwise, it's vertical. Um, so we could do this. Else 0. Some vertical else 0. If horizontal equals 0 and vertical equals 0. If they're both, if we set them both, then do we just set the score equals horizontal times 100 plus vertical? Oops. Self score. Oh, we can't do the things like that. We have to do it the other way around. Let horizontal equals if let some horizontal horizontal else 0. Right? It would be nice if I could have done that, but let vertical is equal to this. Vertical else 0. Oops. Got the equal sign. If let. Come on. There. It's a different number. So some of them actually have doubles. 35, 539. Is that bigger than what I tried? 3544. It's too low. Okay. It's still too low. All right. How do you debug something like this? You can print out all the scores. See if something pops out at me. Yeah, so, okay, well, let's just double check to see. This one's saying it has a vertical reflection at 1. 2023, 13. Come on. Input. This one's saying it has a vertical reflection at 1, which is not true. Okay, so we have a bug. And this one's saying it has a horizontal at 5 and a vertical at 1. Okay, so everything's getting a vertical at 1. Where does this pattern actually reflect? I see something here, but that doesn't go all the way. I don't see a horizontal reflection anywhere, because I don't see 2 duplicated rows. So it's got to be a vertical reflection, but where is it? Horizontal 2. Here? Yeah, it's close, right? Because it's just off by this 1 bit. And it's not this here, because this doesn't work. Here it is. Here it is. It's a vertical, whatever this is. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13. Okay. So this should be a vertical 13. And let's create another test input. And grab it. Put it here. And we'll use this as our decoder ring. Right? And then we'll go back to the vertical stuff and then print out the stuff again. Row colon 2 and all these 16s. All right, I'll do it. I'll do it. Let W equals self width. Change all the 16s to CF6 to be 0 W $. There. Blah. So it should have found it right away, right? After the first couple of shifts. Oh, I'm trying to do the whole thing. I should be just ending it with. I think this is backwards. Now that I've done all this, I think I need to do it this way and shift it up this way. Although I thought I tried this and it didn't work. 13. Okay, there you go. Now it works. All right, we got that working. Let's go back to our other thing. Oh, and now we can't find scores for this pattern. Wonderful. At least we get the pattern. So it's 1, 2, 3, 4, 5. The fifth pattern down. So let's throw that in our test input. 1, 2, 3, 4, 5. Is it this guy? Yeah, it's this guy. No. Oops. No. There he is. I knew it was in one of those buffers. All right, so what should this be? This should be, oh, this is a horizontal one that's failing, right? Because it's reflecting here, here, and, oh, no. I'm missing this bit for this guy. So it's got to be a vertical. Oh, and again, it's the last column, right? These two. This is the death of me, isn't it? All right, let's print it out as we do. It seems to be the way to get this thing resolved. It should be here that we find the match. Oh, wait a minute. Okay, yeah. We're shifting this down. We definitely want this to only compare the last two bits. Oh, my brain. Right. When we get to Scoop says you can do if config bang test. Oh, I didn't know about that. I did not know about that. Thank you. Let's try that. If cfg bang test. Nice. And then to turn it off, false. Oh, that didn't work. How about or true? There. That works. When we get, yeah, see it compared these two bits. What I need to do is compare these two and see that they're equal. Oh, God damn it. I don't know. I think we do need these things, but just reversed. So we have pattern bits here, reflect bits here is 1 shift width, self width -1. And I just want to compare these. Oh, and I got to shift them. So it's here where we see the 2 zeros that should match. But these are 2 1s. So it's the next one here where this matches this 0 match. Oh, okay. So if I reverse these guys, I'm not going to change it in the code yet. I just want to see if this would do the trick here. No. Because when we get down to 1 bit here, we want to be checking it against a single bit over here. But I tried that, and that doesn't work. As we shift into the reflector, we need to keep moving upwards within the reflector and keep moving downwards in the pattern. But at some point they cross over, and you can only use the number of bits you have in the pattern to compare against the reflector. Scoop says, you know, if you just rotate the pattern and run through the function, it already works. Yeah, there's got to be a way to get this to work, though. And I'm almost out of time, and we haven't even gotten to part 2 yet. How would we rotate this? Yeah, rotating a pattern would involve going bit by bit and inserting into row by row. But here's the problem. The annoying thing is that this thing takes in a pattern thing. I'd have to build a new pattern, a useless pattern. We would have to. I have to think of it as a for loop first before I do any iter folds. Oh, CodeMonk says generate the column data as you parse the input data. We could do that. Oh. And then when we do the convert, does that work though? No. Okay. I'm just gonna fight my way through this because doing that is too much of a refactor and I don't have the time. I want to get this to work. Bikolov, thank you for the follow. So we have a pattern 1010101. And the first thing we want to do is see where it reflects. So we have 0, 1, 0, 1, 0 on one side and 1 on the other side. And then we have 0, 0, 1, 0, 1, and then I guess 0, 0. It starts with 1. Like that. And we shift it down by 1, right? And add it here. And now we want to see, did we just come up with a reflection for the first 2? Near 704, thank you. Thank you for the follow. Near 704 asks what font I have. I think this is just Monaco, the default, whatever the default is for Mac OS. And then this becomes shift down again, and this one goes over here. right? And then what we need to do is compare this ANDed with these lower bits. And as we shift up here, I wonder if we could do it ANDing the two sets of bits today. We're going to get it. I'm going to get it at some point. It came up with a 1. All right, now it's time to try the real input. Uh-oh. Where's that 1 coming out of now? Here. Oh, that's right. I'm printing all the scores out. Okay. Let's do the real input. It found everything. 35691. It's a little bit bigger. Oh, thank goodness. Finally got the right answer. And Scoops, if you're watching this on VOD, sorry it took so long before you were able to get it. All right, we're good. Wizard says once the right pattern gets longer than the left, the master gets smaller again. Yeah, so that's what I did with this thing here. I just stripped them out. Okay, so yay, finally. Git status. Git commit. Oh, git add. I'm just going to do this. Git commit make warnings go away. And then git add source, git commit 2023 day 13 part 1. All right, let's see what part 2 is. Wow, that took me way too long. That should have gone a lot faster. You resume walking through the Valley of Mirrors and smack run directly into one. Hopefully nobody was watching, because that must have been pretty embarrassing. Upon closer inspection, you discovered that every mirror has exactly one smudge. Exactly one dot or hash should be the opposite type. In each pattern, you'll need to locate and fix the smudge that causes a different reflection line to be valid. And this is highlighted. The old reflection line won't necessarily continue being valid after the smudge is fixed. Oh. So does that mean that it might find an alternate, but still find, like if we found a vertical one, it would now find a horizontal one, or would now two horizontals? Mohad says that you did notice in a lot of cases it would be almost reflection except for one bit. Yeah. So maybe it's a vertical versus horizontal thing. Let's find out. So we have to check each bit. What's the number you get after summarizing the new reflection line in each? So it's got to be a new reflection line. All right, so we can change that. We check that because we have the score. I'm going to try brute forcing it. I'm sure it's a more elegant way to do it. 13. So part 2. For Pat in self patterns. We're going to duplicate it because we're going to be bit twiddling here. Let mut pat equals self pattern clone. For row in pat.pattern.len. Oh, self. What am I doing? Pattern clone. There. Row in pattern len. For call in pat width. let bit is equal to col, no, 1 shifted by col. Yeah, and then we're going to say pattern row exclusive OR with the bit. Then we'll try to generate a new score. And now we have the possibility of not getting a score. And I don't want to set the self score here anymore. So I'm going to change this without trying to break part 1. What was it? 35691. I'm going to change this to return the score value. And change this back to non-mutable. So we can just do this, and it'll just return 0 if you can't find the score. Okay. And now, back in part 1, we changed this to be self patterns iter map p score, like that. Oh, well, we do want to save the score for part 2. All right, does that still 35691? Okay, so I haven't broken that part yet. So now what we can do is we can call score on this thing here. If let, oh no, we could just say let score equals pat score. If score is not equal to 0, and I'm gonna have to take out the code that doesn't find a pattern, right? Score is not equal to 0 and score is not equal to pat score, then we found a new score, right? Let mut total equal 0. And now we found the pattern, so we can just go to the next pattern, right? I'm sorry, we found the smudge. Continue next pattern. And then if we come through here, we can say println could not find a smudge. And then we can deal with that problem when we get to it. And then this just becomes, ooh, that was bad. That's not what I wanted to do. No. Come on. There, jeez. My fingers are just not behaving today. Oh, we need to flip the bit back. Let's flip the bit back. If we couldn't find it on that particular one. All right. Let's see what we get. Oh, computing, that means we're getting a lot of output. Could not find a score for pattern. Right. Okay, so let's ignore that for now. So we're close. We got to figure out why we couldn't find smudges in some of them. And let's print those guys out, right? See if they make sense. Right? Okay, can we find a small one to look at? Oops. Maybe this guy? Right? And then we have to do this thing. Okay, let's go back to the test input and see what's going on here. So it was able to find a horizontal flip, 100. But when we tried to look for a vertical, it could not find one. Is there one that's close to being a vertical? Oh, wait. I think I know what the problem is, or at least one of the potential problems is we're searching for both here. And I'm just returning both. I shouldn't be doing that. I need to be looking to see. I need to be looking here to see if we have a score that's different, but I want to ignore the previous score and score the other one. So how about this? Let's return both of them separately. Like that. And now part one has to be smarter. Let HV equals P score. If H is not equal to 0, P score is equal to, if H equals 0, V, else H. Oh, H at max V. How's that? Does this still give us something? No. Oh, right. Now we have HV. And now we have to compare here. If P pat score is equal to H and V is not equal to 0, then total plus equals V, continue next pattern. Else if pat score equals V and H is not equal to 0, total plus equals H, continue next pattern. But it's also possible that it's equal to neither. Right? We want to be able to double check. And Wizard says if you mirror between 1, 2, and 3, 4 and flip a bit in 5, they still generate a mirror match. Yeah, so that's what I'm trying to do, is verify that I'm not using the same one. If H equals 0 and V equals 0, continue. Okay, so now we know that at least one of them is not 0. And I think that covers all the cases. Nope, could not find a smudge. I'm assuming, right? I'm just assuming that it's going to switch from vertical to horizontal, and that there aren't two patterns that are vertically or horizontally reflected. Let me just double check here that we're going through both. We're finding both. And then we just return the score. Oh, yeah. Good, Monk, you're right. I got to switch the bit back. Maybe I should do it in a block so I only have one place to do that. If H not equal to 0 or V is not equal to 0, then we do this. And that way I always flip the bit back. That was a bug, but it wasn't the last bug. I guess the question is, all we have to do is find something different. If pat score is not equal to V and pat score is not equal to H, then total plus equals v plus h, assuming that only one of them are non-zero. Continue next pattern. Yeah, except it's zero. V not equal 0. And oops. Oh, I missed the 0. Still no. Oh, else. Oh, that doesn't matter though. Whew, this is tough. Let's see if we can visually find the smudge. All right, we got 100 out of it, which means it's a horizontal here, right? And I can see the horizontal there. If we flip a bit, oh, it looks like maybe we do get another horizontal here. Aha. So how do we do that? We have to find the next horizontal. Should this return all? Instead of returning an option usize, it should be returning an option vec usize, or just a vec usize of all the ones it found. That's a bigger refactoring. We'll have to do the same thing for vertical. Vec usize. Let answer equals vec new. Instead of return, we want to say answer push. And answer push I plus j. And continue to the next try. Answer push I plus j. Answer. And I forgot to make it mutable. And then we have to do the same thing for vertical. But now we don't have to do all this let sum business, because we'll just return self find horizontal, self find vertical. I'm going to break everything, aren't I? Okay, let's go down to vertical. And this should be a vec of usize. Let mod answer equals vec new. And then where do we return? Instead, we're going to say answer push. And then just answer. And what blowed up? Oh, right. Now we have two vectors that we have to deal with. And in part 1, it should be straightforward because hopefully there's only one match in each puzzle. So we should be able to just sum them all up. And that's the score. H iter chain V iter sum usize. All right, and now we have to deal with this. I just want to make sure I haven't broken part 1 yet. Oh, right, I got to switch this back. CodeMonk says, yes, part 1 has exactly one match. Okay. 645. Oops. I really broke it. I really broke it. I mean, All right, I have to return HV. Huh. Oh, right. I have to multiply H by 100. Ah, I forgot. Maybe I can do that inside the H's themselves. Answer push I plus 1 times 100. Right. Yeah, 3, 5, 6, 9. Okay, good. All right. So now we're going to get a list of all horizontal and vertical values here, and we're going to search in them for one that does not equal. Yeah, I guess we don't actually even need to separate this out. We can just return the chain. Let's do that. H.iter.chain v.iter.collect. Right? And that way I don't even have to do that up here. I can just say p.score is equal to p.score sum usize. Nope, I forgot I did that. Let's do this again. Oh, I can't do that. Bzik 775. Welcome. Thank you for the follow. What are these? These are vecs of usize. And those are vecs of usize. And I can't build. Oh, copied. Collect. All right. 3, 5, 6, 9. Okay, so we still didn't break part 1. 36 up. And then I can just say here scores. And I can say if scores all x equals 0. Oh no, I'm going to say any x is not equal to 0, right? Then we'll come in here and say for score in scores, if score is not equal to pat score, then we found one. Total plus equals score, score, continue next pattern. Let's see if that works. All right, here's where we set the bit. Here's where we clear the bit. Oh, we need to make sure we clear the bit here as well. Oh no, we don't care because we're just continuing to the next pattern. Okay. We only care if we haven't found one. Okay. Iter, any? Dang it. That's probably all of them. Oh no, it's just some of them. Okay. No. How many are there I can't find a score for? Oh, could not find a score. Oh yeah, I don't care if we can find a score. Yeah. I was thinking that was the smudge thing. Oh, look at that. We got a number. 39037. Hey, yes. And just in time too. It's 8:57 a.m. and I got to get going. Let's check in with Clippy. Clippy wants me to change this thing. Oh yeah, there's no reason to cast as usize. That was back when it was a U64. And then we have this thing here. I guess we could just change that. Yeah, make sure I didn't break it. There we go. Good Monk says that's the right answer. Yeah. All right. Mizzard, I'll take a quick look, but I gotta get going. Copy link. What do we got?